This is lesson 6.1, Systems of Equations. In this chapter, we will deal with systems of equations as well as systems of inequalities, and we will learn different ways to solve and graph these. Okay, so let's start with lesson 6.1, where we will basically be graphing systems of equations and finding solutions by looking at a graph. Okay, first thing I need to do is define a system of equation. Here's your definition. A system of equations, are two equations that are solved simultaneously. A system of equations may be consistent, and that is when a system has at least one solution. When a system has at least one solution, it is said to be consistent. Consistent means there's at least one solution. It could be consistent, independent, which means it's exactly one solution, or dependent, whether there's an infinite number of solutions. Or a system of equations may be inconsistent, where the system has no solution. Okay, so we have consistent, independent, exactly one solution. Consistent, dependent, infinite number of solutions. Inconsistent, no solution. Okay, so those are our three possible scenarios. Three possible scenarios when solving a system of equations. The first of the three possible scenarios is the one solution. You will find that your system of equations has one solution when the graph of your system has intersecting lines. If the two lines intersect, the solution is the ordered pair where those two lines intersect. So in this problem, both lines intersect right there, and the solution would be -2, -1. So this is the first type of scenario that you will find where your system has one solution. One solution. Okay. Now I said three scenarios. Let's look at the second scenario. The second scenario is your no solution. Your no solution. It is possible that when you graph your system of equations, you will find that there is no solution to the system because the lines are parallel and they have no points in common. Parallel lines never intersect, so parallel lines have no common points. These lines have the same slope. As you already know, parallel lines have equal slope, but they have different y-intercepts. They intersect the y-axis at different points, and that makes them parallel. So in this case, our solution is no solution. Okay, and then the third type of system that we have, or a solution that we can find, is where we have infinitely many solutions, where both equations are actually the same line, and therefore these have all points in common. All points in common. And here's what that looks like. It's one line. You just have one line both equations happen to be the same exact line. And so both equations have as many points on a line they have in common. So we write our answer this way. Infinitely many solutions. That would be the way you answer the solution of a system that turns out to be the same line. Okay, let's start solving systems by graphing. Copy down number 1. Okay, on number 1 we have a system of equations. Here is your system of equations. 2 equations that are going to be solved simultaneously. Now I wrote down m equals b equals for each of them because we're going to use that to graph both lines on the same coordinate plane, okay? All right, so I'm going to go ahead and color code these so you know which one I'm doing when. So for the first equation, y equals x plus 3, my slope is 1 over 1, my y-intercept is 3. And my second equation, y equals negative 2x minus 3, my slope is negative 2 over 1, and my y-intercept is negative 3. So what we need to do now is graph both of these on the same coordinate plane, okay? And so just to make it easy for us to read, I'm going to color code the equations. I'm going to make one red and one green so that you know which is which. Okay, let's work on the first one. My y-intercept is at positive 3, and my slope is 1 over 1. And there's that equation. Okay, the green one, my y-intercept is at negative 3, and my slope is negative 2 over 1. I want to rise and run as long as I have to until I know exactly the point where they intersect, like I can see here. Okay, so there's my line. Now let's look very closely at the intersection point. It's right there. Okay, so it's at negative 2, 1. That would be the solution to my system of equations, and I would show the graph to prove that that's the point where those two meet. Okay, so this system can be classified, if you're asked to classify it, it can be classified as consistent, independent. Because it has one solution. Okay. All right, here we go. Number 2, please write down your system of equations. Write down your system, please. 2 equations that we're going to solve simultaneously. All right, so again, I'll just work with the first one in red. My slope is negative 4 over 1. My y-intercept is negative 1. And the second one I'll do in green. My slope is negative 4 over 1. My y-intercept is 2. Now just looking at the slopes of this equation and looking at the y-intercepts, I know and you know that these lines are parallel. I know and you know that there's no solution because parallel lines never meet. You still have to graph them. Okay? So here's x and here's y. And let's start with the red one. My y-intercept is at -1. And I will go 1, 2, 3, 4, down 4 to the right 1. 1, 2, 3, 4 to the right 1. And I'll do the same going up. 3, 4 to the left 1. And 1, 2, 3, 4 to the left 1. So there is the red line, the red equation. And then let's do the green one. So my y-intercept is at +2, and my slope is -4, 1. One, two, three, 4. Okay, they're very, very close to one another. However, they are not going to ever intersect. And I have to see that you know that they're parallel lines. So these, the solution here is no solution. You could also draw the symbol for no solution. And if you're asked to classify this system, you would say this system is inconsistent. It's inconsistent because they have no points. These two equations have no points in common. Okay? Okay, number 3. Here's your system. Remember that a system is when you have two equations and you're going to solve them simultaneously. Okay, so we'll work with the first one, and we notice right away that it is not in slope-intercept form. Okay, so the first thing that I'm going to do is, off to the side, I'm just going to change that equation, y minus x equals 3, to slope-intercept form. So let's add x on both sides. Y equals x plus 3. So let me rewrite it. Y equals x plus 3. Notice my slope is 1/1. My y-intercept is 3. And for the second equation, my slope is 1/1. My intercept is 3. It's clear to see that these two equations are actually the same exact equation. Sorry about that. These two equations are really, truly the same exact line. So we're going to graph it. Okay? I'm going to graph it in purple because really both of them are one line. I can't graph it in red and green. So let's start on my 1, 2, 3. My y-intercept is at +3 and my slope is 1/1. So there's your equation. There's your line. Okay. Because both of these, wow, that's really bad. Hang on. Let me, can I do this over again? This is horrible. Can I do this again? It's really, really bad. Let me try it again. Okay. All right. Because both of these equations have every point on that line in common, you're going to tell me that this equation has infinitely many solutions. What are the solutions? All of the points that run on this line. Okay? And if you were asked to classify this system, you would say that it is consistent, dependent, because it has infinitely many solutions. Okay? Okay, let's look at number 4. The sum of Sally's age plus twice Thomas's age is 12. The difference of Sally's age and Thomas's age is 3. Write and solve a system of equations to find their ages and interpret the solution. Well, we don't know Sally's age and we don't know Thomas's age. So I'm going to let Sally's age be represented by the variable x, and I'm going to let Thomas's age be represented by the variable y. And then I'm going to take each of these statements and I'm going to translate them into an equation, okay? So, let's start with the first sentence. The sum of Sally's age plus twice Thomas's age is 12. So let's write that. The sum of Sally's age, which is x, and twice Thomas's age, which is 2 times y, is 12. Okay? Now let's go ahead and look at the second sentence. The difference of Sally's age and Thomas's age is 3. So the difference means when I subtract Sally's age minus Thomas's age, the difference is 3. So write and solve a system of equations to find their ages and interpret the solution. Okay, so here is my system. I've written the system of equations. Okay, let's go ahead and find the solution by graphing. Okay, so I'm going to go ahead and look at this one. I need to find m equals and b equals. So the first thing I'm going to do is I'm going to take this equation and get it into y equals mx plus b. So let's subtract x on both sides. 2y is equal to negative x plus 12. Divide by 2 on both sides. So y is equal to negative 1/2 x plus 6. So my slope is negative 1/2. And my y-intercept is 6. Okay, now let's look at the second equation. I'll do it in green. X minus y is equal to 3. Let's get this into slope-intercept form. So subtracting x on both sides, negative y is equal to negative x plus 3. Let's divide by negative 1 on both sides. So y is equal to x minus 3. So in this case, m is 1, or 1 over 1, and b is negative 3. Okay? Alright, so let's go ahead and graph these two equations. Okay? So let me go ahead and set up my x and my y axis. Okay, I'm really only dealing with positive. No, I'm not. I'm dealing with negatives also. Okay, so we can do that. That's not a problem. I'm just running out of room a little bit, but I'm okay. That's okay. All right, so this is x, and here's y. And let's start with the first equation. Let me recall that my y-intercept is at positive 6, right there, and my slope is negative 1, 2, negative 1, and 2, negative 1, and 2. And if I went the other way, I have that. Okay, so here is the first equation. Right, looking at the second one, I have to start at negative 3, and my slope is going to be positive 1. So I'm going to rise and run literally until I see exactly where the points meet. Hang on. Okay. I just realized that I had it on pause while I graphed this. Okay, so again, the first equation has a y-intercept of 6 and a slope of negative 1/2. The green equation, the second one, has a slope of 1 and a y-intercept of negative 3. And as you can see, these two equations intersect right there. Well, let's see what point that is. It's where x is 6 and y is 3. So, go back to the original question. X is Sally's age. So that means that Sally is 6 years old. And y is Thomas's age. That means that Thomas is 3 years old. Let's make sure that it makes sense to the description given to us. It says the sum of Sally's age plus twice Thomas's age is 12. So 6 plus 2 times 3 is 12. Yeah, that's right. And then the difference of Sally and Thomas's age is 3. 6 minus 3 is 3. Okay, so that's what the solution means. That x is for Sally's age, she's 6, and 3 is for Thomas's age, he's 3. Okay? All right. Independent practice. Read the directions here. It says use the graph at the right to determine whether the system is consistent or inconsistent, and if it is independent or dependent. So for 1, 2, 3, and 4, you're going to have a classification. It's either consistent, independent, consistent, dependent, or inconsistent. Okay, so those are your possible answers for 1, 2, 3, and 4. Okay, then you're also going to work on 2 of these. You're going to solve by graphing. Number 3, there's your system. And number 5, there's your system. Okay? All right, jot down any questions. We will continue discussing systems of equations and graphing systems of equations tomorrow. God bless you and have a great night.